So do we need to start immediately or as soon as people start coming in?
I think maybe we just allow a few minutes for people to come in, and then we can start off. So gentlemen,
Okay, so
please
we
be
are
a bit
good.
patient. Ladies and gentlemen, please, a little bit, some patience, please. Thank you.
Okay. My alarm. We'll just give everybody a couple of minutes to join us. Okay.
I want to suggest that maybe we start off and or do we wait for another minute or two?
Oh, sorry, I was talking and the line was muted. We will start at 10:05 on the dot.
Okay, that's in another minute.
Yeah.
Okay.
Just one more minute. Can you all see me and hear me properly?
Yes, ma'am.
Yes, okay, thank you. So, we start. This is Mass Timber Construction in Nigeria, webinar series 4.0. How does mass timber require different thinking by architects and engineers? Ladies and gentlemen, distinguished guests, built environment professionals, forestry professionals, and participants, good afternoon from Lagos, Nigeria, and a warm welcome once again to another of our webinar series on mass timber construction in Nigeria. This is the fourth of 6 series which commenced on Wednesday, 19th of July, and has been held on the first and third Wednesdays since commencement. My name is Abimbola Ajayi. I am an architect, and I'm honored to serve as the moderator for this important conversation that explores the potential of mass timber construction as a sustainable and innovative building solution in the Nigerian built environment. Our webinar today is on a topic at the forefront of modern construction. How does mass timber require a different thinking by architects and engineers? We are here again today to further explore the transformative potential of mass timber. Hello, can you hear me? Hello, please, can you all hear me?
We can hear you. We can hear you quite well. Please go ahead. Thank you.
Oh, okay. We are here again today to further explore the transformative potential of mass timber as a building material and delve into the innovative ways it challenges architects and engineers to reimagine the art and science of construction. We are also exploring how this innovative construction approach can contribute to the Nigerian building industry and address the unique challenges and opportunities within our own country. Over the next 2 hours, we will yet again unravel the sustainable, structural, and creative aspects of mass timber, showcasing how this remarkable material is reshaping our architectural landscapes and pushing the boundaries of engineering. Mass timber construction offers an exciting prospect as it promotes the use of renewable resources, reduces carbon emissions, and provides faster and more efficient construction processes. I encourage you all to actively participate and engage in this webinar, ask questions, and share your perspectives. Your contribution is vital in shaping the discourse around mass timber construction and its potential role in Nigeria's sustainable development. Please type your questions in the chat room for ease of collation. And if we have enough time after the presentations and answers to questions, we will welcome comments from participants who are inclined to do so. Please register your presence in the chat box. Give us your name, where you are from, and your email address. Get ready for another enlightening journey into the future of construction as I introduce our expert speakers today, Franco Piva, Leander Moons, and Damien Mock. And very quickly, I want to go through the profile of our first speaker, Damien Mock of Agodamos Engineering. I hope I'm correct, Agodamos Engineering. He's a structural engineer and the founder of Agodamos Timber Engineering and has been working in designing wooden structures for over 15 years, taking care of all aspects, statics, building physics, to 3D drawings and CNC machine programming. He has designed dozens of buildings in Italy and abroad, particularly in Europe, Australia, and North America. He has published 3 books on wooden construction and often speaks at international conferences. He promotes the need to have a holistic approach to the design of mass timber buildings to ensure their durability and performance while keeping costs low. Franco has adopted and implemented the DFMA, that's Design for Manufacture and Assembly approach, in all his projects, an approach strictly related to digital models, information sharing, detailing, and on-site problem prediction in a 100% BIM workflow. Ladies and gentlemen, professionals, built environment, forestry professionals, please welcome Franco Piva as he takes us through a journey for about 20 minutes. And I would also like to inform us that Franco would have to leave us for another very important meeting this afternoon. So if you have your questions for Franco, kindly type in your questions as well in the chat box. Welcome, Franco Piva. Thank you very much. Over to you, sir.
Well, thank you very much, Architect Jay, for this nice introduction. And especially thank you, Mr. Ibukun, for organizing, for putting so much efforts to promote the use of mass timber in Nigeria. I'm starting my presentation, so second. Sharing the screen.
Yeah.
Okay, here we go. So one thing more about the introduction made by Architect AJ. In 2 days, exactly September 8th, it will be exactly 20 years I've been working in the timber industry. So it will be such a great anniversary for me to celebrate. And in the next, I can anticipate that in the next few weeks, I will write something like, how was the timber industry 20 years ago? And was so different. The world has completely changed. The world of timber industry has completely changed in just 20 years. It's just crazy what happened in this market. So I'm very happy to be here and to promote, try to contribute somehow to promote more the use of mass timber in the building industry. So very quickly, a few words about my engineering firm. The name is Gutomus, and I created it in 2007. Of course, I'm running this company now together with my great colleagues. They are working in Italy very hard. We have constantly in contact with them, of course. And yeah, for about 15 years, we worked in more than 18 countries, and we engineered something like 350 master buildings. Most of them are located in Italy, but 6 years ago we started working abroad. So it was a big challenge, and it's still an adventure. It is a long journey, but at the moment I'm here in Canada because we have some projects here. We are working on some projects here, so it is great. The world of mass timber is really great. We worked, as I said, in many different countries. At the moment, our main market is Scandinavia, especially in Denmark. We are engineering one of the largest mass timber buildings in Europe at the moment in that area. But we also engineered many different projects in Australia, Singapore, North America. And there is something moving in South Africa as well. So I really hope there will be a new green country very soon in Nigeria. We will add like a new flag for us. We say in Italian that we add a flag when we have a new project in a new country. who we work with. The company, the engineering firm works with the producers, with designers, and with developers, general contractors, investors in general. But the most important part, in my opinion, of our job is that we work with the producers. So when we work with the producers, we prepare 3D drawings that are so perfect, so good, so super detailed that we can create the CNC files from that 3D model. So you see something on the screen, we share the IFC model with our client, and they will receive on site the element, timber element, exactly as it was on his screen. And this is the most important part, the biggest difference of timber compared to other building materials. I'll go back later to this concept. I want to spend a couple of words about this picture, because this is an architect from Nigeria, is Kunle Adeyemi, and we worked together with him for a kind of a crazy project in Venice for the Biennale of Architecture in Venice in 2016, because we developed together a floating structure on 3 levels, and this is me discussing together with him about the solutions, about how to lift the structure. We offer 4 different services to our client: value engineering, which means to reduce the cost of the structure, analyzing the assembly time, the quantity of material, different types of connections are really the key of the timber construction. If you do not design properly the connection, the costs could be much higher, or you could have a lot of problems on site doing the assembly. Then, of course, we make the structural analysis. We also take care of the project development. It's very important to manage the project in a proper way to get the trucks at the right time with the right materials on them, or to get the containers, because in many cases we work so they have to transport the materials on container.
Permit me to interrupt you, Franco. There is some background noise from your end.
I know I'm in a quite noisy area at the moment, because I'm this is
Okay.
a company we're working with in Canada, and they allow me to use this desk. They cannot do anything else. So,
Okay, please go ahead, but speak a bit louder. Speak a bit louder.
I can't, because there are many people around me.
Oh, I see. Okay.
There are a lot of people, and I can't speak louder. If I
Please
put
go
the
ahead.
microphone closer,
Yes.
is it better?
Yes, it's better. Sounds better now.
Let me check if I can. 1 second. I was looking if there is the option. I want to be sure that the microphone is not the one of the webcam, but it is this one. Check super. If I can.
You can move the microphone closer to you. We would hear you better.
Is it better now, or is it worse?
Yes, it's better. It's better now.
Okay, let's try this. It is a different option for the audio input. If it doesn't work, just raise the hand and I will try to make it different. So I was saying that the most important service we offer is DFMA. I will get back later to this more specifically, but it stands for Design for Manufacturing and Assembly. So it means that when we design the structure, when we make a structural analysis, always keep in mind how the elements will be produced, transported, and lifted and assembled on site. We must always have this in mind. There is an element connected to someone else. These 2 elements must be lifted, transported, and produced. So we start from the end and we go back to design the element. We need to know all the story of the elements since the beginning. And as you said, architect AJ, we are facing new challenges now. We need to promote the use of mass timber. So Einstein once said many years ago that the measure of intelligence is the ability to change. And now we have the chance to change. It is not too late, probably. We have the time to change the timber industry, or as timber industry, we can do our best to do this, to go for more sustainable materials, more green materials, and to improve the quality of our buildings. Just to show you what is happening around the world, what's been happening in the past, for the past 30 years, more or less. In 1995, the sum of the maximum capacity of all the CLT producers all over the world was about 25,000 cubic meters per year. 10 years later, it was about 100,000 times. This year, by the end of this year, 2023, they expect that the maximum capacity, the global maximum capacity, will be almost 3 million of cubic meters. These numbers are unbelievable. I think there are no other materials in the team building industry that have such a big grow in the past in such a short time. We're talking less than 30 years. I started working here in 2003, and the global production at that time, there were just 2 producers, and the global production was about 60, maybe 70,000 cubic meters per year. So from 2003 to now, the difference is amazing. I like to say that timber is not only a sustainable material, it's not only the greenest material we can use in our building, but especially is a digital material. So I really believe, and I prove this every single day, that timber is a digital material, and it brought a huge revolution and an evolution to the timber industry. Timber allowed us to use in a very good way technologies like BIM, computational generative design, parametric design, offsite prefabrication. We can really go for offsite production. We can really go for offsite design and save a lot of time on site. We can we can go for offsite, sorry, not offsite, and reduce a lot of times the hours we spend on the project on site. We reduce the assembly time, reduce the risk of having problems on site. So in this way, DFMA, again, the acronym I love, Design for Manufacturing and Assembly, can be seen as a new value engineering tool. What do I mean for that? I mean that if we timber engineers, together with the other designers, architects, mechanicals, acoustic experts, etc., if we work together to find all the solutions to all the problems and to solve all the problems at the very early stage, keeping in mind all the process, production, transportation, lifting, assembly. In that way, we can reduce the global cost of the structure, and we can we can make timber the most cost-effective material to go for.
We should not walk in the vision.
So I wanted to have this slide to show again what DFMA means, and I like to use this short movie to tell you what I mean for DFMA. We need to raise our point of view. We cannot just stay on the ground and look at our feet. We need to raise a point of view to understand what is around the building. We cannot be just structural engineers, just acoustic, just building physics, just architects. We need to have a holistic approach to the design and to look at what is around our building. Can we transport something big on site? How big the crane is? Can that crane lift the elements, or are they too heavy? When we work in Australia or in North America, they transport the CLT pallets with CLT, with container. So we need to know, can we load that element in the container, or is it too big? So this is what I mean for DFMA and for holistic approach to the design. And all these things together allow us to avoid this problem, which is the most frustrating part of our job as designers. We draw something, we dream of something, but then on site, there is something different. Timber allows us to give an answer to this. Because with Timber, we create a 3D model, an IFC 3D model that can be easily shared, imported in Revit, ArchiCAD, Allplan, etc. A 3D model that can be explored by all the designers. And once they say, yes, it's okay, I need a hole here or there. Once we all agree that this is the final model, then we can prepare the production drawings, the CNC files. That's why I say that in the 90s, it was what you see is what you get. But now in 2023, it is time to talk about what you draw is what you get. It means you see something 3D on your computer, you can deeply analyze the 3D model, and then you create a 3D file for the production. Exactly as it happens with the 3D printer. You draw something in Rhino or whatever, and then you transfer to your computer, to the 3D printer. 2, 3, 4, 10 hours. You have your item, your toy, your object produced by the 3D printer. No matter how complex the 3D model is, because the hardest part, the most complicated part, will be to prepare the drawings and not to create the element. This is exactly how we work with Timber. We spend a lot of time to think about the production, think about the 3D element, but once the 3D element is ready, it is very easy to be transferred to the CNC machine and to be assembled on site. So the 3D model we share with our client is something like this. You click on an element, and thanks to the IFC technology, IFC format, you read all the information connected to that element. You click on this, you see that it is a column, mechanical grade GL28H is a European standard. You see the name of the producer. You can see that it will be delivered on the first truck. The position number is a unique ID that identifies this element for the assemblers. And then, of course, you read the dimension is 600 millimeters by 600, and the length is a bit more than 6.5 meters. And again, this detail is very complex. It will be impossible to be made precisely by hand, but possible theoretically, but very, very complicated. We draw this, no matter how complex it is. We send the files to the CNC machine, and they will get this element on site. So if you need, as an architect, as a mechanical engineer, you need to have an extra hole somewhere here. They just let us know what they need, and we prepare the element with that hole. We pre-drill. We made that the production, because we do not produce anything except digital files. We tell the production to produce the elements exactly as we want. And the same thing is also for the connections. You click on an element
Right.
and you see that it is the name of the connector, the cost of the connector, how many screws. So it is very easy to go on site and check if the assemblers are working well. You go there with your iPad or with your tablet. You have the IFC model, you click on an element and you see who that element is. How big should it be? How many screws should we have on that connection? You do not have to go back, look at the papers, the PDF file, print something. You go on site, you just check on the digital model. The digital model is something unbelievable. Once you start using IFC and the digital model, this changes completely the way you work. The last 3-4 slides are about this project we recently completed in Australia. It is a huge project, a lot of trusses. And then on the first floor, there are these CLT panels. So this company has the trucks on the ground level and the offices on the first level. They integrated the slab into the trusses. We work closely side by side with the architects to design also the steel connections that are 90% not exposed. All the slotted steel plates are completely hidden. Nothing will be visible except for the bracing system. So we work closely together with them to make them nicer or good for the architects. This is another project to show you how we shared with the client the drawings in Revit. We shared the IFC file, they opened in Revit, and they could overlap the two models, their architectural model and our structural model, to see if everything matches. A couple of more things. Sorry, I forgot this, the last 2 slides. Many people are talking about BIM, building information modeling. If we use BIM in a good way, then it is a great weapon. It is a huge weapon we can use to value engineer the project, especially for team. But if you do not use BIM in a proper way, BIM can be called BDM. Instead of building information modeling, it is building these information modeling. So we really need to use these digital tools in a much better way. Last thing, to wrap up all these things, why BIM is so important with timber. The main reason is that you can control 100% of the process. You can merge different IFC files, no unexpected events on site, and you can very easily manage all the logistic aspects. Every designer, every person involved in the project can check the model, can see if it is okay, considering his needs, mechanical, steel, etc., etc. So they can really, you can really read everything about the model. Another super important aspect: timber can be seen as a digital material. What does it mean? It means that the model is just an endless sequence of 0, 1, 0, 1, etc. And the details, no matter how complex they are, they can be produced by a CNC machine very precisely. So again, it is very important to understand that the most complicated part of the work will not be the production of the elements, but will be the production of the drawings of the 3D model. of the CNC files. Once these things are ready, then everything is much easier. So that was the presentation. I hope it was very interesting for all of you, and especially I hope that you learned something new, or you saw a different point of view for the timber design, for the timber industry.
Thank you very much, Franco Piva. That was quite enlightening, even though short, but we thank you for your contribution to this discussion so far. Now, we have just one question in the chat box for Franco. And the question is from Wabi Isaac, who said, what's the difference between BIM and BDM? What does the disinformation stand for? I think I quite understand what you meant by disinformation, but please you can enlighten us. And if you have if anybody else has questions for Franco, kindly type in your questions very quickly because he has to leave for another meeting. Thank you very much. Over to you, Franco.
Well, BIM is when everything works well. Building information model. So they give us the information we need. We send back the information they need. Building this information modeling is like a joke I made, is when we need something, but they send us something different, or we send the model and they are not able to read it, so they ask us to make an extra work to explain them how the model is. Let me tell you something about that. When you work in a group of different teams from different countries, different workflows, etc., the common language must be IFC. The common language must be BIM. So if I speak English and another company speaks French, another company speaks German, then there's no way to understand each other, and it would be a mess, the project in general. Sorry for the word, but it would be a disaster, the project. So BIM is when everyone speaks the same language. BDM is when everyone speaks a different language.
Thank you very much, Franco. Well, we will need to leave now. If there are any more questions for Franco, please type it into the box, and I'm sure that if Leander Moons or Damien Moore can answer on your behalf, that's fine. Otherwise, we would send further questions to you, and would kindly request for your response to such questions so we can forward to the participants as well. Thank you very much, Franco.
Sorry, one more thing.
Yes.
Jay, I read a question about the IFC. If I can take this question super quickly.
Oh yeah, I just saw it. Yes, let me just read it out. How is the information maintained in IFC files, since some properties are lost when IFC is created from Revit, for example? So please answer that very quickly so we can move on.
Yeah, there must be a BIM manager or someone who knows how to export, import the IFC file. Yeah. So in that way, it is, at least this is how we work. We always make some tests with the different designers to be sure that the properties we export with our software are correctly imported in their software. But especially with the IFC version 4, they improved quite a lot this part. So generally, they can see all the properties we add to our drawing.
Okay. Okay. Thank you. Thank you very much. Thank you so much, Franco. And I wish you success, more success in future, and congratulations on your 20th anniversary of being involved in mass timber construction. And I really look forward to being like you in 20 years' time as well. Thank you very much.
I wish you this as well.
Thank you, Franco. God bless you. Have a good afternoon. Thank you.
Thank you, everyone. Bye.
Now,
Bye.
bye-bye. Bye. Very quickly, we'll move on to my colleague. I call him my colleague. His name is Leander Moons. He's an architect and designer, co-founded OMT Architects in Berlin, Germany, and they are also established in Kenya, East Africa. He is the founder of Leander Moons Incorporated in New York, USA, now known as Leander Moons BV, located in The Hague, Netherlands. Leander Moons and OMT Architects are creating innovative design solutions based on local practices and options. In addition to the sustainable character of the designs, flexibility in use and implementation is a key contributor to the success of these projects. Both companies work seamlessly together from the concept design phase through the project deliveries on site. They aim to create and implement sustainable, equitable, and empowering design solutions and build projects with the innovative integration of locally resourced sustainable building materials with a special focus on timber, which has become the focal point in their most recent projects. Leander has also been leading international consultant teams for complex projects around the globe. He contributed to the realization of numerous projects in different building typologies, and his works have received multiple architectural awards. The Office for Mass Timber aims to contribute through projects and visions to a sustainable future. The OMT values local traditions and supports the empowerment of existing communities through connecting with these communities and in combination with the research into local construction methods and resources. They have developed innovative design solutions. Implementation of sustainable materials such as timber is combined with flexible spatial layouts to support long-living and adaptable buildings. Leander Moons graduated from the Delft University of Technology in Netherlands with honors in the fields of architecture, urbanism, and building technology. He is registered as an architect in the Netherlands and previously in Berlin, and as an international associate in the American Institute of Architects. It is my utmost pleasure to present to you Leander Moons, who has spoken to us on the first edition of this webinar series, Introduction to Mass Timber. Very enlightening, very educative, very intelligent and expert. Leander Moons will share with us from his wealth of experience once again on mass timber construction and why architects and engineers require a different thinking in construction methodology. Over to you, Leander. You're welcome once again.
Thank you, Architect Ajay, and thank you for the great introduction. I don't need to say a lot more about myself, so let's dive right into it.
Please
let me
go
share
ahead.
my screen.
Yeah.
So, and let me just put this bar out of the way. Yes, so mass timber in Africa. I think we hear a lot of experts talking, and we set up this series also with the intention to focus on Africa. And when I opened my own office, OMT Architects, a couple of years ago, it was actually the aim to think how can we, like in Africa, contribute to a more sustainable environment, construction environment. And that was, of course, with the material which has to be sustainable, mass timber. But how do we start that? That was a big question then, and I think it's still a big question now, because we hear a lot of like different conversations going on, but how do they apply on Africa? And I think especially when we want to open a market in Africa and think about how mass timber could like deal with the challenges we're facing in Africa, especially the demographics, we also need to look into what are actually the local conditions and what are the chances within this local condition to work with mass timber. Of course, that starts with just, how much forest do we have? That's an easy thing we can track. So the more forest we have, the more viable also building with timber becomes, because there is a local product which we can use in an industrial way for value creation in forms of real estate. And then as like an engineer or as an architect in our case, we have to look a bit broader than what we normally do. It's not the building we're designing. We have to look at this whole value chain, basically from growing the seed to the tree, to harvest that tree, to manufacture. Franco Piva gave us like great examples of like how can you use modern tools to do that, to then eventually the architecture, which is just a little portion of our work as architects nowadays, and especially when building with timber. And we should not forget that when we build with timber, first of all, like to a lot of people, this will sound like a risk. So how, when we approach a client and want to convince this client that we're going to build with timber, how do we convince them? And you might think there's something wrong with this slide because it's 2 times the same picture, but actually that is the way we are trying to convince clients. So the houses you see here, they're partly built conventional, they're partly built in timber. You cannot tell from the outside. Maybe if you have some knowledge, you can, but most people cannot. And still, some of those are called best practice. They represent a lot of value, and others are considered risk, but they look the same, they feel the same until you go inside. And there, of course, the next step is when you talk with the clients, especially in the African context, a lot of people from Europe, from the US, they will tell you the big benefit of working with timber is that you need less people on site. Now, in the African context, that is an argument we rather don't want to use because actually employing people is a great way of adding value to the project, to the local communities. So we actually have been monitoring how many people do we need on the site. And here you see 2 pictures. On the left is a stone brick house. On the right is a timber house. It's both teams of 12 people. It's the same people we need for both projects, actually. But they work in a much better condition. They work off-site. Partly, they have like a clear construction site, not all this rubbish and waste which we have on site. So we create much better working conditions for the same people. Funny thing, for example, in Zanzibar, where we are building a lot of our projects, is that the factory which employs like the people working on their sites is the only employer on the island who has like construction workers on the payroll, as where all the other companies work with day loan workers. So it's a huge improvement of like their job. That's why everybody on the island now wants to work in the timber construction industry and not in the conventional industry anymore. So we can create change. We can think also about like offsite production being a lot safer than on-site, where cost work is just like pulled down, and where we can make in a controlled environment, in a shaded environment, in a weather protected environment when it rains, the elements, we prefabricate them, and the workers have much better working conditions. So they have a security of job and much better conditions to work in. So you can start to wonder, you know, what is safe, what is value, what is risk, and I always like to compare that to the car industry. Who 5 years ago would think that the car industry would evolve towards electric? Some people, they would have already thought so. Others still these days are not convinced about it. And I think timber is in a similar state where you can think about, is this the building material of the future? You will have different opinions about that, but it definitely will play a huge role. Franco Piva showed us some great graphics of where production goes to. So how do we then work with that as architects, and what is actually different? So the first thing is like really getting the client on board with all these elements I touched upon before, to then make the decision to work with timber. Our first multi-story project was this project here. It's Moyoni Homes. We built 20 buildings of those, all sold out very slowly at the beginning. Then when the first building was built, very quickly. And we now got just commissioned for the next project of 20 buildings of the same type with some minor tweaks. And this building takes it simple to start with. Now we heard from Franco, there's great opportunities in very complex geometries, industrial processes, but when we don't have the industry for that, we need to start simple. So we looked into where actually does like the CLT, the mass timber, make the most sense, and we identified that this is the ceilings. So because this is the first multi-story building, we used then the ceilings as mass timber, and we used like the regular timber framing for the walls. These were prefabricated, as I've shown you before. So the buildings were actually erected very fastly from construction of like the base plate, which actually takes the longest time, towards like then the completion of the roof takes just 3 weeks. So the building is assembled in a very quick time, then only the fit out takes some more time to then complete the buildings. And again, if you look here to the left, a conventional site, you see all the rubbish behind it, and you see what a clean site you have. That's of course another big advantage of working with timber. It's much less waste, much more effective use of resources. So that's then when the upper floor comes up, and again, these buildings are a week apart, so it goes super quickly to just pull them up. And this is then the interior which you get. And of course, when it's only the ceiling, it's relatively simple because you can put all your electricity in the walls. For example, we opted to use wall lights instead of roof lights, just to simplify the construction. And of course, we could integrate a lot of these things in the timber, but it also creates all unique elements and a lot more complexity to the project, which is not necessarily necessary at that point in time. At the same time, as architects, of course, we look into conventional ways of like dealing with climate. Timber has a great effect in our context, which is a very humid and tropical climate, that it doesn't store the heat. So when you have cross ventilation, as you can see here in the apartment, the building will automatically cool out, and the ceiling will not radiate the heat as a concrete ceiling would do. So in a much nicer interior climate, and actually that is what also a lot of the clients appreciate when they step into a timber building in a tropical context. The building just feels a lot cooler. So we took that also into other projects, and of course, this project is fantastic. It was again very slow selling at the beginning. A lot of people thought it's risk. Now we have one building almost completed, and all of a sudden everybody does want to buy that building. So we're again opening some building blocks which we closed before. And it just shows that like the first building and the work to convince people that this actually can be done is very important, and people don't believe that when it's on paper. They need to see it in reality, and now we can start to see this. And this project is a lot more complex because, as you can see, it's not only the ceilings working with timber, but a lot of the wall elements as well. And this is, of course, very important in the planning process. And that's why I put this picture in here, because it shows you how we then try as planners and architects to take an influence on how we use different walls, different materials, to also integrate the necessary electrical systems, AC systems, and other things in the structure, which, of course, when people are used to work with conventional means, you just like pull it in there. It's a lot easier to integrate that. You cannot do that in the same way in timber. So it does create a different approach in how you design the building, a lot more detail, not only in the connection detail as Franco showed before, but also in the fit out has to go into that. On where do we apply all these things, and how does that impact also the way you use the room? Of course, that should be minimal, but yeah, normally you would have probably some more sockets and lights also in other walls than when you concentrate it in one. But this is for us because we want to be very resource effective. So we don't want to make double walls. We want to show the timber wherever we can and use like the thermal benefits from the timber to enhance the living qualities. And the same is of course true on the facade. Again, a timber frame facade is very simple. A full mass timber facade is a bit more complex, and it's just here shows a little bit. We need to ventilate behind the facade, so it's more complex details, and it all can be done, but it just adds a different layer of craftsmanship, and of course it comes to a different price. So what we are doing a lot in our projects, and Franco also mentioned that, is value engineering, 3D tools. So IFC, yes, I can completely relate to that. And properties for us are not always as important, because we as architects define basically the architectural outcome, so the volume or the massing of the elements, as you will, but we don't like integrate all this detail of the connection that comes in later. So I don't need all those properties in my model. That means I can also use more like affordable software to produce that same IFC model, which will then be lifted up by the engineers and the manufacturers throughout the process. So also that, I mean, for us as a small office stepping into this, we cannot afford working with Revit. So we work with Rhino, we work with SketchUp and tools like that to simply create models which still can be effectively exchanged with the manufacturers to create the buildings, as you see on show in this presentation. And at the same time, we of course also look into how do we need to set up these buildings. So this is the same building, and the colors stand for the material. So we look closely into, you know, it's great to do all of this in CLT, but does it make sense? Do we have clients who start complaining that like their sockets cannot be there where they want them to be, and that they maybe don't want so much timber around them, but the ceiling and some other elements would be enough? Most of all, of course, they complain about cost. So we look into how can we effectively merge all these different elements and let the project benefit from that. And for example, with this project, through that stage and through that like value engineering process, we were able to almost cut out a third of the construction cost, a third. So it's very beneficial to think about how do you actually work with timber, and where does which timber system makes most sense. And of course, that was for us very important, because what we actually want to do is like the other projects you've seen, they reach from the row houses $200,000 to 60,000 for like the 3-bedroom apartments. And with this project, JJ, we are aiming for the local population starting studio apartments at $10,000, and we are able to do that in timber, actually also competing with conventional building methods. And of course, doing that is a lot of learning of this previous process. How do we optimize that? Not only learning from like the modern projects, also learning from like the local projects. We looked carefully around, and we've seen that there is a lot of timber often in a context, and we, you know, because we get so used to certain buildings, so used to now building with concrete and concrete blocks and bricks, that we don't even see how much timber we used to use in the past. So you see that like these old buildings, which are very iconic for Stone Town on Zanzibar, are very similar to like the design we made for local housing solutions. And of course, that goes also a bit into the architecture. I don't want to go too deep into that, but between public, private, semi-private orientation, all these things we need to loop into our timber buildings, just as we do into conventional buildings. Plus, we also need to think about diversity, diversity in timber systems, but also diversity in the housing itself. So we develop like our timber skeleton, so to say, to enable like different variations of apartments to be integrated in that building. We developed 64, like in the first building, they will only use 12 different ones, but all that within like the same framework. And again, that relates always nicely back to the car industry. You can choose a car and then you can choose your color, different fit outs, a longer version. So the same, our buildings should work. We should not make repetitive buildings with only the same apartments. And that doesn't matter if we build a conventional in timber. Now, if we think about timber as a material, it's very important to think about this, what Franco Piva called the DFMA. So how do we assemble this? And for us, the engineers and Franco also like to talk, of course, about the complex solutions. Actually, we working in the African context, we always think, how can we simplify the solution? How can we simplify using 3 different panels, which all are different in its shape, and make 1 panel out of that, which we can use 3 times, and it spans the whole building instead of 9 different panels spanning the whole building. Of course, this panel is optimized to fit in the container, so it's less than 12 meters. And a lot comes down to, and this is a little look into the kitchen, is to left you see the first building we built, and on the right hand side you see the second building we built. Same building, but very different solution. I think when you look at the detail, you can already see how simple the right detail looks in relation to the left detail, and I don't want to go into the whole depth of that, but that is what we're trying to do. We're trying to say, yes, we don't want to combine concrete here and get like a difficult connection in terms of reinforcements. We just want to put this rail, and this rail can be put on at the specific height we need. We know a concrete is 2 centimeters a floor off, timber is only a few millimeters off. So if we put this support into the concrete, we know it will not be there where we need it. So we need to create simple details which can be adjusted on site to allow for like the installation of these panels in an effective way. The same here. For the first building, we used CLT walls, but we wanted to source them from the African continent. So we went to South Africa, and we found out that the properties of their panels are quite different of like those coming from Europe, because of like the wood growing a lot faster. So it made us to rethink connection detail, and we came up with this detail to add some mass there where the support cannot burn away in the case of fire. But we stepped away for that for the second building, came with a simpler solution where we still use CLT, a bit more CLT in the ceilings, but less in the walls, and therefore replace that with local timber from Tanzania, a lot more cost effective and just as good when it comes to fire, plus also a clearer and simpler connection detail. So that is the kind of ways we are looking into simplifying timber construction in a local context, which this detail might look very different, for example, if we do that in Nigeria or when we do that in Europe, but this is like now the most optimized detail we found for the Zanzibar context. And I think that is key. Of course, the other big thing, and that we all should keep in mind when we start planning with timber, is fire. Everybody will ask you about fire, so you have to have a good fire consultant on board, make up a system on how that works, because that question will come in every single meeting you will have with a potential client who would be interested in timber, and then with everybody living into a timber building. So fire, modular system, simple solutions, and that allows us then to now construct this building. The containers have arrived on site, so I hope in a couple of months I can show this building actually standing up. Here on the right you see the panels in South Africa, the left is a construction site. So I'm very curious to see how fast this building will come up. I think by the end of the year it should be fully assembled, and then in the end it should look like that. So that was just a very short oversight of how we work with timber in African context, and of course happy to take any questions, and looking forward to Damien's contribution to today's webinar. Thank you.
Thank you very much, Leander Moons. It's always a pleasure and a delight to hear from you, because it just shows that the possibilities are just endless, and it's also a good thing that you are actually making all this talk come to life. Thank you so much, and we will have some questions afterwards for you and Damien to answer to. But very quickly, let me take us to the profile of Damien Mock. Damien Mock is a mass timber and sustainable construction enthusiast. He's the owner and head of engineering of Mock Engineering in the city of Cape Town, Western Cape, South Africa. Holding 20 years experience in the built environment, Damien brings extensive knowledge in the analysis and design of high-end residential homes, retail and commercial multi-story buildings, and industrial structures. Collaborating with some of South Africa's foremost architects, Damien has twice formed part of a Fulton Award-winning team in 2011 and 2017 for remarkable Cape Town homes. Damien has been lead engineer on numerous unique builds with a strong focus on projects that require a high level of design input. His hands-on approach and attention to detail allows him to work closely with clients and other professionals to produce optimum engineering solutions for even the most ambitious of architectural designs. After 18 years in the industry, working with and learning from esteemed engineers, Damien started his own consultancy and launched Mock Engineering Limited in July 2020. In November 2022, an opportunity to strategically partner Mock Engineering alongside the Sustainabuild Group presented itself, which he grabbed with both hands and no hesitation. Having always had an interest in timber engineering and witnessing the growth of mass timber industry in Europe and North America, Australia, and New Zealand, Damien's passion for sustainable construction has been spurred by the growth of his two daughters and the thought of what the world will be like when they grow up if the construction industry, particularly in South Africa, continues to do things the way that it always has. It is my utmost pleasure, ladies and gentlemen, to present to you Damien Mock, who will share with us from his wealth of experience on mass timber construction and why architects and engineers require a different thinking in this construction methodology. Thank you very much, Damien, for accepting to share with us today. Over to you, sir.
Thank you very much for the introduction, Architect Ajayi. And good day to everyone that's tuned in. I'm very glad to see this, and I'm very honored and grateful to be having been included in this. I just want to start off by saying me sitting next door to the likes of Leander Moons and Franco Piva, I'm but a novice in this arena, but what I lack in experience, I make up in enthusiasm, and the experience is just a matter of time. So I'm really looking forward to seeing the growth of this industry, not only in South Africa, but the rest of Africa too. I feel like it has enormous potential. Okay. So how does mass timber require different thinking by architects and engineers? So I have a quote stuck in my head that came to me about 2 years ago from a developer who approached me when they encountered difficulties on a site they wanted to develop, where they wanted to put a student residential apartment block on an empty site. It's in Cape Town and it's very close to a transport node, a major transport node, and it's also very close to the University of Cape Town. The developer had designed the building with no parking on it. At the time, there was a bylaw allowance by the City Council to construct buildings with no parking if you met the requirements of being close to a transport node, which this was. They finished the design of the building in regular construction, timber framed and masonry. But just as they got going with that, the geotechnical investigation came in, and it was found that the site had terrible founding conditions, which meant that they would have to embark on a piled foundation system, which of course comes with cost. As they got going with the final design, they then were stymied by another hindrance, and that was they found that the city had a servitude running through their site, and this was an undocumented servitude, which of course affected their design, and the servitude was for a sewer line that ran right the way across the site. And so unfortunately, what it meant for them was that they were unable to place any foundations for their new building in a 9-meter zone right across their site, which was unfortunate for them because what it meant was their plan of that bottom level of the building, they then had to avoid having any foundations in this entire zone right through here, which meant they had to straddle the building right over it, which meant they had load concentrations on each side of it. And then it just pushed up their cost and of the foundations, and eventually the entire project became unfeasible. the developer, who was also an architect and was aware of the mass timber making waves overseas and other parts of the world, went back to his engineers and said, well, look, seeing as mass timber can be up to 70% lighter than regular construction, how about we design this building as mass timber? And shockingly, their response, as I've shown on this slide, was that, look, you're going to have to find another engineering firm. We do not know anything about mass timber, and we don't feel like going back to university. So he then had to amicably terminate their appointment, and he, through LinkedIn, had found our practice. Contacted us and said, listen, I have this building, it's completely designed, but I want to do it in mass timber. So we grabbed the opportunity with both hands, and my colleague in my office, Carl McClarty, that was one of his first tasks. He designed the building in mass timber. So if we look at a typical floor plan it was a 4-story building, and in my opinion, 3 to 5-story buildings are the sort of golden sort of height for timber and mass timber buildings. You can go higher, but you start encountering problems at high levels. But that's the sort of golden mile for timber and mass timber construction. So this was a 4-story building, and this was a typical layout of a floor. We had 6-meter spans, 6-meter spans in the one direction and 7.5-meter spans in the other direction. So fairly nominal spans, pretty easy to design. And because it was the same floor plate all the way up, with the exception of the ground floor where we had to span over, which it was much easier to achieve in mass timber. If we look at the elevations on the building, you can see the look of the building lended itself to being mass timber. And we finished the design of the entire structure: columns, beams, floor plates, roof, the works. And unfortunately, at that point, the city council had lost a court application to dismiss that bylaw, which the city lost. And because this developer hadn't started on site, their approval was rescinded because they didn't have any parking on site. So for no other reason, nothing to do with mass timber, the project was cancelled. But what it brought to light was the original engineer's stance on this building, saying that they don't know mass timber, they're not going back to university, potentially would have led to them losing the opportunity to work on what would be the first mass timber multi-story building in South Africa. So before I jump into how we should be thinking differently, architects and engineers, I just want to touch on 2 aspects of why we should be thinking differently, because often I feel that if you want to figure out how to do something, have a solid why behind it, and you'll very quickly figure out how to do it. So touching on the carbon emissions, and a lot of people may be familiar with this, but for those of you that don't know it, it's worth knowing that here's a quote from the World Green Building Council stating that buildings, and by buildings they actually mean the built environment, is currently responsible for 39% of global energy-related carbon emissions. 28% of that is operational emissions from heating, cooling, and powering the buildings, and already there are strides being made in bettering those industries. But 11% of global energy-related carbon emissions is down to materials and construction methods, what we're building with and how we're building it. So mass timber, being a construction material, ties in immediately with the materials. And mass timber, as we've now seen with both Franco's and Leander's presentations, has the potential to completely change the way we build our buildings. So it's worth stating now, just again, a lot of people do know this now, it's making waves all around the internet, but 1 cubic meter of wood sequesters 1 ton of carbon dioxide. That's an enormous amount. So for every cubic meter of trees that grow, you're sequestering or taking out or absorbing 1 ton of carbon dioxide out of the industry. Whereas concrete, on the other hand, for every cubic meter of concrete produced, there is between 290 and 410 kilograms of carbon dioxide emitted into the atmosphere. This is an interesting pyramid. It's a construction materials pyramid. You can just Google it. It's available online. It's a calculator where you can just click on various materials that you're using in your building, enter how much of it you're going to be using, and it'll kick out how much carbon dioxide is being emitted into the industry. But what it does very neatly portray is how, for instance, aluminium sheet is sitting at 28,242 kilograms of carbon dioxide emitted for every kilogram of aluminium steel. Sitting in the next tier down, there's structural steel over there, but the minute you take structural steel and you galvanize it, you're right up into third place. Sitting a bit further down, in the middle over here is concrete. This is obviously the lower end of concrete, obviously a lot of fly ash in it, which is displacing the cement. And that's sitting at 288. But interestingly, right down at the bottom over here is wood, and not only is it near zero, it's in the negatives. So all of these materials, varying from plywood, so to even get them from the forest to a material that you can use to build with, they're still sitting in the negative range, which is why, and this is how most timber built buildings or mass timber built buildings are achieving net zero ratings in their carbon emissions, which of course they get benefits from, and of course which they're incentivized to do. So I've long held the view, and both now Franco and Leander again have touched on this, is that we need to industrialize the construction process. We need to move our labor force off the construction site where it's unsafe and very difficult to work, and bring them into a controlled environment where they're not exposed to weather conditions. They can work a full day unhindered. They can be skilled. They can be skilled to come in and do the same job, and which increase their output and increase quality. And by using mass timber, you can also produce a better product. This is a chart that I like to show because it just shows, it really shows why we need to be changing what we're doing. This is a productivity GDP value add per employee by industry. So it basically shows the productivity levels of an industry. And you can see, so sure, it ends in 2012. But I can tell you now, nothing's changed, or not much has changed since then. The advent of BIM and that sort of thing, so they probably made things a bit better for the construction industry, but not by much. And you can see how the manufacturing industry from 1980 to 2012 absolutely skyrocketed in its production levels or productivity, whereas construction is still sitting way down at the bottom. What's more noteworthy is that construction actually is dropping, meaning basically we're getting worse at what we do in the construction industry. So my thinking is, look, why not use what the lessons from the manufacturing industry to pull the construction industry up and make it more productive, resulting in a better industry. So in order to move this along and to move it along, we need to change the preconceived notions of timber buildings. A lot of people think that 20 years after a timber building is finished, it's going to look something like this, and we need to change. This this notion. This building is the current tallest mass timber building in the world currently. It's not only mass timber, it's a concrete and timber hybrid. It's called the Ascent Tower, recently completed in Milwaukee in the States. The bottom 6 floors are concrete structure for the parking decks, and the upper 19 floors are all mass timber with concrete cores, elevator cores running up the middle. Here's a short video just showing the construction process of this building. So you can see the upper floors all in timber. So what you need to note here is that while the foundations were going in and while the first 6 floors were being constructed, the mass timber portions were being fabricated in the factory. And it's worth noting again that as Frank had pointed out, each one of these timber elements is specifically marked and packed in a way and delivered to site that it's offloaded and the crane knows exactly where it goes. These guys were able to construct this building with a 1,600 square meter floor plate at a rate of a floor per week. So once they started the timber portion, they were constructing a floor per week. And what that means is that they finished the upper 19 floors, obviously 19 weeks. And also because it was all timber, they had no backpropping on any of the floors, meaning that they could immediately start with closing up the building and starting finishes inside a floor as soon as the floor above it or 2 floors above it were complete, and which allowed for the construction process to speed up incredibly. So a lot of people ask about the cost of mass timber, which is a fair question, but the short answer is, pound for pound, it is more expensive. However, what it allows you to do, and by industrializing the process, you can speed up construction immensely, and that is where the cost savings come, both to the client or developer who gets their finished product earlier, which means they can start generating profit off it earlier, and to the construction company who can finish a building quicker and move on to the next one. So step one, in my opinion, is to start with a mindset for both not only architects and engineers, but all consultants involved in a project, and including developers, because that's where it starts. We need to move away from the fixed mindset of, look, I can't do this. It's not good enough. It's too hard. I don't know about it. I'm rather going to stick with what I know. I know there's other materials. I'm rather going to stick with that. And we need to move into a growth mindset of saying, look, I'm good enough. I can try something new. We really need, I've identified the problem. I need to do something about this. It's going to take additional time. It's going to take additional effort, but we need to do something, and we can do this. This is an excerpt from a wonderful story that from a book that was given to one of my daughters. It's called Rosie Revere Engineer. The quote that I like to bring out of it is, life may have its failures, but this was not it. The only true failure can come if you quit. So essentially, it's going to take a level of courage from architects, engineers, other consultants, and developers to embrace this new material. It's not actually a new material. It's just new in the scene in the form of mass timber. Timber's been around for absolute centuries. Just interestingly, there's another book called Iggy Peck Architect, if engineering is not your flavor. So here we have the 4 major materials, and everyone is familiar with all the details associated with masonry, steel, and concrete. The thing about mass timber is a lot of the details are very similar. And so you don't need to view this as some kind of problematic material. In a CLT slabs, you can screed onto and apply the same finish as you would to any other building. The edge details, the windowsill details, and a lot of these details are very similar, and it doesn't take much to familiarize yourself with them and then become comfortable with using the material. Before I move on, I just wanted to point out, where do you get information from to get yourself familiar with mass timber? And there are a couple of places or websites I just want to point out. The first is a local website called the Wood App, and it's set up by the Stellenbosch University, a collaboration between the Stellenbosch University and the Department of Forestry in South Africa. And they've currently loaded up to, I think, 9 courses on mass timber. It's really aimed at people who are unfamiliar with it, whether you're an engineer or an architect or any other person in the built environment industry, and you can go and complete those courses. They're free, available online. Just Google the Wood App, and as far as I know, you can, if you're a South African registered architect, accumulate CBD points from those. I stand to be corrected on that, but as far as I know, you can. The second one I want to point out, is the Woodworks website, put together by the Wood Products Council in the US. This website has an absolute library of information freely available to look into mass timber, be it from high level esoteric aspects right through to technical discussions and papers. Then Franco Piva's website, he too has a very interesting section on technical articles, discussing anything from advances in mass timber or right through to the history of mass timber. Then from a code perspective, because these are obviously it's obviously information that us as especially engineers need to be compliant with, and I would recommend going to the International Code Council and looking up the international building regulations. Heavy reading, but certainly worth it. And then, of course, there's the Eurocodes for especially angled at engineers, for you to go through and just familiarize yourself with the design process before you can start specifying or designing buildings using this material. But this is not what I want to focus on as part of my discussion. What I'd like to focus on is the construction process, the phases of construction. Again, both Franco and Leander have intimated this. Typically, and this is I'm going to use South Africa as an example. I'm quite sure it's very similar no matter where you are. And this is the engineering process, and the architectural process is again very similar. But a typical construction process from conception right through to construction for us obviously starts with inception. We get appointed and we sort out our P's and we identify any tests and stuff that need to take place and advise the client accordingly. That's all fine. But this is where the trouble usually starts. We start with concept and viability, and at this stage, usually there's only the client, the architect, and the structural engineers on board. And we then advance, we then take the architect's concept drawings and produce engineering concept drawings. Those concept drawings then go to to be costed, and that produces a cost estimate for the client, and from that point they can decide whether this is a feasible project or not. It's not a bill of quantities, it's just an estimate, and then they know whether they can proceed with it. But importantly, from an engineering point of view, the structure needs to be designed at this point. It may not be detailed in a model yet, or to that sort of nth degree, but the concept is there. Every structural element needs to be there at this early stage. But usually, again, at this stage, it's only the structural engineers and the architects on board. We then move into design development, and from design development, you would move to documentation and procurement, the tender process. And by that stage, you need to have all your details and documentation all resolved. However, which is a point that is quite that happens on a lot of projects that we have, the mechanical, electrical, and other consultants, fire consultants, such may only be appointed deep into stage 3. When they come on board, they'll come on board with their designs, which can affect the work done up at this level over here in concept and viability. That means that the engineers then have to change their design and come back down to here. And then often then you end up in a process of just going backwards and forwards between the consultants, stymieing the process a bit before you can actually go out to tender. And that then is a hindrance on the design process. Then finally, we get to tender and documentation. And once that's all in order, we get into construction. Now, a problem that I've seen come up over and over again in projects is that the design development phase can sometimes last deep into the construction process. And that can completely hinder the construction process. A lot of the details, especially architectural detail, can typically only get resolved, and clients only making decisions on design aspects deep into the construction process, which then means that you're stuck in this process of jumping around between all these phases, which then means that you never actually get to close out. You get stuck over there, and then the delay process, the delay claims start happening. often a little bit of mudslinging happens around there. You do your best to avoid any of that, but ultimately everyone loses out and the building gets delivered late. So that's the process that I'm saying, look, this definitely needs to change. So in the mass timber construction phases, but this doesn't only apply to mass timber. This is basically the design for manufacture and assembly process, no matter what material you're using. Mass timber just right now is a very good material to take full advantage of that process. So starting with concept development, you move straight into engineering modeling. And what's important is that at this point, over here, you really need to have all of your consultants on board at that stage, very early in your in the design process. This is a difficult pill for clients or developers to swallow, because it means they need to pay those fees up front, and often they don't know the feasibility study hasn't been done yet. They don't know whether they actually are within budget on this project. So that's just a challenge to get by. But you need to have them on board so that the engineering modeling, again, this is where Franco Piva was talking about, is that the engineering model can be complete, because once you go from engineering modeling, you move into the pre-construction phase, and that's the phase now where you're moving from there into the next step being shop drawings. Now, shop drawings is an antiquated term. This is essentially the detailed broken up IFC file that gets sent to, in this case, mass timber manufacturers, where they'll break up the entire building into each individual part, a column, a beam, the various floor slabs. And by that stage, you need to have every duct and every service hole identified in the building. You can't come later and decide, no, you needed another hole through a beam or through a column or through a floor slab. Because once you push go on those shop drawings or on that completed BIM model, from there it goes off to the mass timber suppliers or producers, the guys actually making the mass timber product. Because for them, their steps go very quickly. They go from production, they'll source the mass timber products, they fabricate those mass timber products, so they'll take the CLT slabs and immediately start cutting out the notches and the holes and whatever needs to be done with their CNC machines. From there, it goes onto the truck, and from there to assembly and ultimately to closeout. So these 5 steps, from when you push go there, happen very quickly. And if you need to make a change after that point over there, speak to any manufacturer in the production line industry, and they'll tell you, do not mess with the production line. If you stop it there, the entire thing halts, and your cost as a result of that will soar. So, just in closing, I just want to reiterate that for us as engineers and architects, it's going to take some courage for us to get away from our current fixation with concrete and steel, and to say, look, I want to make this happen. The developers of the Ascent Tower that I referred to, they were the ones that started that entire process, and they went to the architect to tell them, we want a mass timber building. But that's not going to happen that's not going to happen in the majority of cases. It's going to take first up the architects, because they are the first ones in line when a project starts. Client usually approaches the architects first up, and then it will be for the engineers. And our responsibility will be to advise these clients and developers when we think a project may be suitable for mass timber, and then to gun for that. Likewise, we also need to identify when mass timber may not be suitable for a project. I've done some work with the guys at Mass Timber Technologies up in Johannesburg, MTT. And one thing that I did admire about these guys is they will off the bat tell you straight up if the mass timber product that you're wanting on your project isn't suitable for your project, because what we can't have is projects out there that start failing or just don't perform because mass timber maybe wasn't suited for that project. So just in closing, I just want to say that so over and above the courage and having the courage to do it, for me the strongest why, and as was in my covering profiles, I have 2 young daughters. They have a friend, a little boy, family friend of ours, who made this for me. This is a little, as you can see it there, it's like a city block, basically. 3 buildings on it, made out of scrap pieces of wood that were lying around his dad's workshop. And he made it for me. Again, it's between 4 and 6 stories, perfect for mass timber. And I'm just wanting to say, you know, let us be the generation that changes that production curve. Let us be the ones that push this industry and just get mass timber into its rightful place as one of the major construction materials.
Thank you very much, Damien. I'm sure that everybody will agree with me that this has been a very, very interesting session, and now you have even made me resolve further that there's no reason why we should be afraid of the future, and we shouldn't be afraid of stepping out into doing new things. Thank you very much, Damien Mock. That was very, very interesting, and I hope we can reach out to you again in future as we go along this journey, because really and truly implementation of this construction methodology is a must in our country called Nigeria. Thank you very much, Damien Mock. Very quickly, we will go to a summary of the presentations for about 2 minutes. I don't know if Architect Biodun Fatuyi is ready for that before we go to the question and answers. This is because we want to give time to the participants to put in all the questions that they have. And immediately after Biodun's couple of minutes, we will have Ibukun Faloye talk about, give us remarks from mass timber construction in Nigeria for another 2 minutes. And while that is going on, please, participants, if you have any questions, type into the box. We have quite a few questions already. So Leander and Damien, please be ready for the question and answer, while Biodun Fatuyi goes through a quick summary and Ibukun Faloye talks to us about mass timber construction in Nigeria. Over to you, Architect Fatuyi.
Yes, good afternoon, everyone. It's been a very impactful session. First of all, I'd like to thank all the speakers from Franco to Leander and, of course, Damien. Thank you very much. Franco opened up the floor talking about wood being a digital material. He said wood is sustainable, but above all, it is a digital material because it helps to make beam faster, and it helps you in your design, it helps in coordination, and that really wowed my mind. Says wood, timber, through beam will make everyone speak the same language because it's very easy to understand. It says it's a lightweight material and very easy to fabricate offsite, which makes it easier and gives us less time to construct. It reduces construction time, which of course on the long run will save cost, because once you save your time, it makes you turn out projects faster, thereby you're going to be saving costs. After that, we answered a few questions before he dashed out to another meeting. And then we heard from Leander Moons. I think Leander Moons has spoken to us before. He's a veteran in mass timber construction, an architect. He spoke to us about the conditions of timber and how it relates to design. He was talking about timber being a weather conducive material, such that it cools the interior even better than concrete. I thought the best material for that was clay, until I heard Leander tell us that wood can even do, timber can even do better. He said it keeps the interior climate cool and doesn't allow it get hot, based on the fact that we are in a very, very what's it called now? Humid area, you know, timber.
Tropical and humid, yeah.
Tropical and humid area will be very good for our location. He also spoke about the design and benefit of timber in how it helps us coordinate our design. He spoke about projects that he has done all across Africa and the whole world. And then we also heard from Damian Mock. Damian spoke about buildings and its carbon emissions majorly, and said buildings contribute 39% of carbon emissions in the world, and that was very alarming to me. He says 29 is from operational activities of the building, you know, heating and cooling of the building contributes 28% of the 39%. And I'm like, wow. So if we neglect these figures, then we now miss the importance of timber. It says 11% of these emissions come from the material and the construction method, and made us understand that wood isolates carbon. So if we use timber, it means that 39% of these carbon emissions from our industry, which is the built environment, will be reduced drastically. And says that concrete actually contributes majorly to carbon emissions. So I think it's high time we move from other forms of construction to timber. He also spoke about the urgent need to industrialize the mass timber construction. And in industrializing that, the construction industry is lacking behind majorly in the wood industry. They showed us a summary, a table that identifies the wood industry as the lowest active in the, the construction industry as the lowest active in the wood industry. He told us that it's time to change our notions on timber building. He mentioned to us that we will need urgently to stop the fixed mindset and move to the growth mindset, where we will say we can try different strategies. Is this really our best work? This may take some time and effort for us to push the industry. He glanced through the traditional construction method, which we all know, the inception to the closeout, concept, design development, documentation, construction. That is what we are all used to, and showed us the mass timber construction process, which first was concept development, engineering modeling, then pre-construction, shop drawing, production planning as number 5, number 6, supply of mass timber products, number 7, fabrication, 8, logistics, 9, assembly, and 10, closeout. Finally, he told us about the cost of mass timber, which of course also be reiterated by Leander Moons, that it is more expensive actually to build with timber, but the fact that it takes time gives us that benefit. And as I said earlier, time is money. So once it gives us the ability to produce buildings faster, inevitably we are also saving time. Thank you very much, and I hope my summary has refreshed our minds a little bit as we continue with the question and answer. Architect Ajayi.
Thank you, Mr. Faloye. Please, a quick word from Mass Timber Construction Nigeria. Quick word, 2 minutes. Thank you, sir. Then we'll go to question and answers.
Thank you very, very much. From mass timber construction in Nigeria, it is obvious that we have come together for a purpose, and the purpose is to birth mass timber right here in Nigeria. And mass timber construction in Nigeria is metamorphosing at the moment into a registered company to see how we can work very closely with partners like Ranko Piva, Damian Mock, Leander Moons, Oliver Orepalu, and a host of other people who are prepared to share their knowledge with us and see how they can impart and develop this industry here in Nigeria to the extent that they can help us in some way train professionals here in Nigeria. So we don't have to bring in professionals when mass timber births in Nigeria. We don't have to import the workforce. The workforce has to be local. And that is why Professor Pakolade and Okedele, we are working very closely with you. We want you to get very interested in how these professionals can help us develop a mass timber curriculum. Remember, Damian mentioned Woodworks. Woodworks is they are restricted in North America. They help develop a timber curriculum, but they are restricted. Those who sponsor them restricts them to working in North America. But that doesn't preclude that we can have some of them to work closely with us to see how mass timber can get forward in Nigeria. Mass timber construction in Nigeria is hell-bent on making sure that mass timber comes to stay in Nigeria. And one of the ways we can achieve this is working very closely with the public sector to see how our building codes could be reviewed. And Damian Mock also mentioned that the international building code, the international codes, so we have that to guide us to see how we can review our building codes. So all these go hand in hand. Mass timber construction in Nigeria is also looking at the forestry side of it, where our focus is on the entire value chain, moving from seed to house. So we are looking at the forestry. Well, from there, we move on to production of mass timber products, as highlighted by Damon and Leander. And this means that we are interested in the entire value chain here, not just the construction, but for forestry. We must develop our plantations in a very sustainable manner such that we can always provide the raw material for the industry. Thank you very much.
Thank you very much, Mr. Faloye. And very quickly, before we go to the question and answers, we will take two quick messages from Architect Yemi Choladibi. I think you are amongst us. If you can say hello to us, I want to recognize you. For you to say, I know that you're in transit somewhere, but please just say a quick hello. You are the chairman of the architects in Abuja chapter of Nigerians of Architects, and then Architect David Majekodumi too. A quick hi from us before we now collate all the questions for answers. Architect David Majekodumi is the chairman of the Lagos State chapter of Nigerians of Architects. Please be on standby. Yemi Choladibi, over to you, ma. Unmute yourself. Unmute yourself. Unmute yourself, ma. We can't hear you. You need to unmute yourself.
She's muted.
Okay, great. Can you hear me now? I was earlier muted by the host.
Yes, we can hear you.
Okay, thank you very much, Dr. Bimbola Jai, for all you do. That has been a very educative presentation by our presenters, and we appreciate them. Also to appreciate everyone that's been on the call. It's a great job we are doing, and we are very supportive of this. My concern is how we can take this presentation to reality, so we can start having mass timber construction building in Nigeria, especially from the low cost housing point of view and affordable housing. If we're able to solve this problem, as we begin to solve this problem, even as we're discussing it, it would be a good, a greater fit and a good idea. Also, the idea of curriculum, taking it to the schools, primary, secondary, and having manufacturers and producers, developers to support, also, partnering and collaborating with government to make this. Let's have a pilot scheme. Let's start, from somewhere. Let's start walking the talk. I think it would be a good, idea if we can achieve this. So I wish us the very best, even as we continue in this. Thank you to Architect Ibukun Falodun for all you do and the good Expo group. God bless us all. I believe we'll succeed as we continue in this discussion. It's nice being here today, and I appreciate it. Thank you for joining us, Bimbo. All the very best.
Thank you so much.
Also,
Thank you.
After Fatui, I see you. Thank you for all you do. After Fatui. Thank you. Thank you. Bye, ma'am.
Thank you.
Bye, everyone. Thank you.
David Majakodumi, over to you very quickly, please. Thank you. Unmute yourself.
Thank you very much. I must say a big thank you to Franco Piva, Leander Moon. Thanks so much. We've been on this together since May, if I remember very well. Likewise, Damian Mock. This has been very, very educative. Not only that, it's a pleasure listening to every one of you. I mean, for the past, may I say, about 6 weeks or 8 weeks now. And it's quite educative. And I must say to the organizers, Mr. Ibukun, Architect Abimbola Ajayi, Architect Oredike, well done. Keep it going. And I believe at the end of this webinar, after the 6th one, we should be able to replicate this, even if it's going to be in a small scale, because my mind goes to each time I go to the Ministry of Physical Planning and Urban Development in Lagos State. Now, there is a little, roughly about, I think it's about, if not 36 or 40 square meter of what is referred to as an eco-friendly building. And all this just got to do with some laser panels, and which is well insulated. And like from what you heard from all the lecturers, the speakers, now this is going to reduce the carbon effect, environmentally, and we need to work more on this. And if at all, we should be looking at within the next 3 months to come up with a little model, using what we have here, so that we can know the shortcomings, whether we're not getting it right in terms of the drainage or in terms of the treatment of the wood. But I must say a big thank you to the organizers of this webinar, and to all architects and all other professionals in the house and non-professionals in the built industry. Thank you very much. And we hope we'll see you at the next Prenoptimate webinar. Thank you very much, and God bless.
Thank you, Architect David Majakodumi. So very quickly, we'll go to the question and answers right now. I also want to recognize a few engineers in our midst. They're my seniors in the industry. Some of them are my colleagues. Because of time, well, I may not be able to see and know everybody, but Engineer Victor is here. There are some engineers, I'm trying to see them, but very quickly, we'll go to the question and answers right now. First question is from Wabi Isaac. He asked some questions to Franco, which he answered. But right now, I think these questions are directed to Leander Mooms. He said, for this Zanzibar project, how are the floor tiles and finishes attached to the CLT timber floors? Secondly, are the embodied carbon calculated and considered in the designs for net zero targets? Then the second or third question is, thirdly, Zanzibar being a coastal area with salts and all the chemical atmospheric pollutants, how is the CLT treated to ensure durable and standing in these atmospheric conditions? Then another question from architect Adenola Adeleye. He said, is conduit wiring and plumbing possible in mass timber construction? Then there's somebody here under the name Samsung SM. Maybe he didn't put, okay, it's architect Afolabi Adifemi. Considering the timber, how cost effective is this in terms of construction cost? I believe that has been responded to by both Leander and Damien. And then from architect Sholade B herself, she said, could mass timber construction be the solution to the housing deficit in Nigeria? And how exactly, considering affordable and low-cost housing? Please, Damien and Leander, go ahead to answer these questions while I gather the others. Architect Fatui, please be on standby to help me with the questions as well. Thank you very much. Over to you, Leander and Mok and Damien.
Yeah. Thank you. There's a lot of questions, so I might miss out on a few. But let me first talk a little bit about Zanzibar and the specific questions to the climate. Of course, the coastal climate is a concern for any building material. I think even more so for a steel construction or a concrete construction than for a timber construction. So what of course is important is that the timber is not constantly exposed to water. So what we have to make sure is that the building is well elevated above like where the water runs. What we actually do is that for quite some buildings, we build the ground floor conventional, especially the multi-story buildings, especially also when they're commercial use in that for acoustical reasons, but also for waterproofing reasons and other reasons like termites, where we also need to deal with. So there's a lot of technicalities in there. I think one of the things which is important to understand in terms of engineered timber is that it's different than the timber you buy off the street. So because this is produced in an industrial process, like the humidity in engineered timber products is a lot lower. That means, for example, that over the past 10 years since we're building, we had not a single case of termite infestation in the wood because the termites don't like dry wood, they like wet wood a lot more. And there, of course, you know, the more passive design measures we take, the better that works. Then in terms of cost, and I just want to, there's quite a lot of like things on cost, and I think it's important to share some information with you. So when we started the process of building timber, it definitely was more expensive than conventional structure. Now with the experience we gathered over the past decade, we are at a point that we are as cost effective as the conventional structure, if not even better. And one of the things we have to take into account is like, where is the material coming from? So we see that by replacing, for example, like high engineered CLT by local wood from Tanzania, it brings the cost of the apartments down, but it has a other very important effect as well, that it starts to generate local wealth. And that wealth directly goes into the people working with the wood in the sawmill, in the forestry, in the construction site, and it elevates their living conditions. And I think this is the important opportunity we have in Africa, is when we now dealing with the demographic challenge where the population of Africa will double, that we use local materials, that we generate local wealth and not import materials from abroad. Now with mass timber, that will be a bit of a challenge, because like there's like always the chicken and the egg, when do you start producing and when not? So we need to combine timber systems, not like look only at mass timber or only at timber frame. It needs to be a combination of that, and that combination needs to make sense for the local setting. And when you get that like balance right, your cost will be right as well.
Damien, do you want to add that, or should I ask more questions?
Sure. Let me just touch on a few aspects there. Just to round this up. So, just to touch on the finishes being applied to mass timber products. Look, with correct planning, you can apply pretty much the same finishes as you would to a concrete deck.
Yes.
What you need to pay attention, you can screed and tile as you normally would on a concrete deck onto a CLT slab, but you just need to be planned for. If you were doing a precast concrete deck with precast planks, you still need to treat those joints somehow, and it's risky putting a brittle finish over those joints. With CLT, we just need to know that upfront about what your finish is going to be, and then we can detail the joints between the panels accordingly to resist any movement between the panels, and then allow for a brittle finish to go over there, or to reinforce the screed, or to go with the structural screed over it. To deal with it, and then the same principle applies to walls and ceilings. We just need to we can design for it. You just need to know upfront. So again, you need that information upfront early. Then just on the moisture and atmospheric resistance. Again, that's all in the planning and details. Typically, mass timber buildings, you'd envelope them, put a finish on the outside. It can be gypsum board, it can be aluminium, but again, we would have seen now where that aluminium sits on the pyramid. But it can be plastered, can be placed gypsum board on it or something, just to protect the timber on the outside. Once you've got the outside envelope closed, you can expose as much as you can on the inside, obviously adhering to the fire regulations. On the cost aspect, I know 2 years ago, a master student in South Africa here did a thesis on the cost of mass timber construction in South Africa, and he came out to just on construction cost, ignoring on material cost, he came out to approximately 10% more expensive. Which was interesting. He had some very healthy assumptions in there, because we don't actually have an active industry here for multi-story building, but he came out to 10%. Interestingly, the construction of the Ascent in Milwaukee, that building's end cost, so even taking into account the fact that it happened much faster, still came out 10% more expensive than what they estimated the traditional build to be. But again, that comes down to the fact that this is the first time people are building with this material. People are learning about it, and the supply. That building construction started just after COVID. There was a massive shortage of timber supply in the States, and all of that timber had to be imported from Austria. So that entire building's timber had to come from Austria. They still achieved net zero on the building, though, despite all those transport costs. But it did add to the actual financial cost of the building, and that's why it came in at 10% more expensive. Very interesting to hear Leander saying that his buildings are now coming in cheaper. It just goes to show this production process and sort of industrializing the process and moving it off-site. As people become more familiar with it, production increases, and off you go, and then costs come down. Just one other side little tidbit on that building in the States. The amount of timber built in that building can regrow. Like, I need to check these figures. It's something that I've read, and it's so unbelievable that I'd love to see the actual numbers behind it. But they're claiming that the timber used in that building will regrow in the North American forest in 25 minutes, not hours,
Wow.
minutes. That timber
Wow.
will regrow in the North American forest in 25 minutes. Show me another construction material capable of that.
We will have to look into that. Leander Moon, do you want to
Absolutely
say
none.
something very quickly?
Yeah, I have a nice
We have
statue.
we have quite a number of questions. Yes, please go ahead, sir.
Yes, I have a nice little anecdote to that. We are planning a 27-story building with timber in Tanzania as well, and that
Yes.
would regrow in 2 days in Tanzania.
Are you
So
sure?
it's yes, the calculation, and that is only in the known like forest. Of course, when you take all the forests together, then it would even grow in a couple of minutes. Timber is a renewable material, and that's really what sets it apart from all the other materials. So we should be using that what grows in front of us.
Yeah. What I like about the timber, one of the things I like about this timber construction thing is circular economy, whereby you can do, as you are felling trees, you are also reforesting and afforesting. You can acquire new forests, you can actually plant more trees. And I mean, sustainability is just what it is. Thank you very much. Now, we didn't answer the question on timber construction being the solution to housing deficit in Nigeria. Well, we've talked about affordability. I guess that would come when there is a volume in construction. Then Ibuku Faloye asked, in as much as architects, structural engineers, quantity surveyors, builders, foresters, everybody, in as much as they all have to work together on mass timber projects at the same time, doesn't the different thinking reflect on the quality of the project, or would it bring a controversy? Now, let me just go on to more questions and comments. Architect Charles Maduka said, this is interesting and challenging. It will be wonderful to replicate this in Nigeria. Yes, I agree with him. Then Agatha Christie Irabo, she's an architect, she's my colleague. She said, I think one of the main challenges we have in Nigeria right now is the treatment of our wood for long-term use in our peculiar climate. When we get this right, there will be no holding back. I agree with you. And then, and then another comment was that we really need to revolutionize this in our university curriculum for the in-depth knowledge of mass timber usage. We agree with you, sir. That is what we're actually working on. So very quickly, while I'm waiting for the other questions, I would have Damien and Leander talk about how this can be a solution to housing deficit. Don't worry about the cost affordability. We've heard about that. And I believe that when we start reforestation, we won't be even worrying about being affordable or not affordable. How can this be a solution to the housing deficit in Nigeria? And how can we all work together as professionals on this mass timber projects at the same time, so that there's no controversy in the quality of projects? Thank you very much, sirs.
So let me start on the affordability. I think a lot of the risk thinking is also applicable on that. We started this journey basically when we had a conversation with the World Bank on what is like an affordable house, and they and this was a couple of years ago, said like it's a 2-bedroom apartment for $25,000. That's what like the market would need to cover like a big portion of like the demographic population who currently has like limited access to housing. So when we started thinking about that, we found out that when we placed our first timber buildings on the market, that like especially people in that price segment were very hesitant to basically sign up for a project like that, because of the fact that they were looking at where are people who do have money put their money, and that is in conventional buildings. So we actually found out that when we started to push for affordable housing at the beginning, that there was no market for that, because these people didn't want to feel like, with the little money they had, that they would become part of an experiment. Now the situation has changed, because we have built high-end housing in timber, and local people start seeing that people from abroad or people from a local context with a lot of money are investing their money in timber housing, and all of a sudden they want that as well. And I think again it's an analogy with the electrical car. Like it needs like some people who are front thinking to invest in this for then the mass to follow. And I think this is one of the really the takeaways and from our experience is that starting with affordable housing only in timber might set you back a couple of years. I think from our experience, and I would have answered this question really a lot different, I think, when you asked this 5 years ago. But our experience is really like that you need to start this from the top, that people see see, yes, this is an opportunity, so that they then follow, and that then the affordable housing market follows. And the big advantage of using timber for affordable housing is because of the production process, the scalability of the production process, and that is where the huge opportunity lies. But I think we still have that threshold just in the society to kind of step over that threshold to really get into timber housing on a large scale in affordable context.
Thank you very much. Now, very quickly, Ekpenyong Nawan Ekpenyong, she's from, I believe, Cross River. Thank you for coming all the way. He says, great presentations. Please, where can the use of mass timber not be suitable? I believe that this question is probably directed at Damien because he mentioned about suitability and non-suitability. I need to ask more questions. I'll put everything together because that actually saves our time. She said, please, where can the use of mass timber not be suitable? And then Wabi Isaac, thanks the presenters. For Damien, how do they reconcile the major design alterations that clients drag into the construction phases, since they have, for example, done CNC machining and the rest based on the phases he shared, and the common challenge of clients keeping the design phase until the end of the project? Yes, that is actually a problem here. You find clients wanting to change design as the project goes on. And for a more general question, have all the presenters worked on projects where green certification and accreditation, for example, LEED or Fitwel, is required by the client? And then, well, architect Fakolade of Anchor University is part of the team actually. It is quite exciting to appreciate the versatility of timber, which we have in abundance in Nigeria. Yes, Leander says that he can grow back his trees in 2 days. I'm sure in Nigeria we can grow back our trees in 1 day. I hope. Our yearning is a demonstration from where we can forge ahead in massive usage. Thank you for the webinar. So over to you. Then Adenle Favor asked that how can mass timber structure be constructed and how tall can this be? That would be the last question for this afternoon. Thank you very much, Damien and Leander. Before we close, can you take those questions?
Sure. So let me just come in on where CLT, for example, is not suitable. Look, it's on a case-by-case basis, but let me just give you an example. So a while ago, we had a development company approach us. They wanted to construct the head offices in South Africa out of mass timber. They haven't built their offices yet. They're still sitting in their feasibility study. But they wanted to do the entire building out of CLT, everything from the bottom up. And when at the time we were consulting with with MTT up in Johannesburg, and they had advised saying, listen, just based on current supply conditions, and but also with your building and what the current capacity of the industry is, we advise that you not do the entire building. And they went so far as to use their expertise, and they've got some very high level architects in their board there, and they went so far as to rather cheekily just took the drawings from those developers, from their in-house architects, and they redesigned the building for them and put together a proposal showing a hybrid concrete and CLT building. And they quite cleverly placed the CLT all around the perimeter and had the inside sort of courtyard out of concrete. And we said to them, this will allow you to get that core up very quickly. You can put your stairs in there. The fire department would love it because you don't have to convince them about the fireproofing qualities of mass timber. They just see some of that people are going to burn inside they're going to burn inside it. And so they put together that proposal, and the CLT on the outside meant that the place where you're sitting and working is all in the CLT areas. You can get all the biophilic benefits from that. And then, but also passers by driving past, all they will see is the CLT around the perimeter. So it's just an example of where we're saying to someone, but look, I mean, there are lots of conditions, maybe in house alterations, or the location or whatever may not be suitable for current CLT products. Then just on on changing the designs during the construction process. And this is where, and I think Franco did allude to this, where BIM comes into it with the full 3D model. Look, in the past, it was understandable that the layman can't read a drawing. They can't see a 2D drawing and visualize the finished product in their head. And this is where BIM and 3D modeling is coming to the fore. So what we can do now is present that to the clients, and the clients can exactly see where every plug must go, what the finished product is going to look like. They can make all these decisions up front. But again, you're never going to get it all done, and you're always going to get those couple of clients that are going to be very difficult in changing things right down the line. You can make a change. They just need to understand it's going to come at a hefty cost. So make sure you understand that before you make that change. It's going to come at a cost, and very often you're not going to know that cost up front. They're going to only know it by the time they fully implemented it. So it's going to come at a cost.
Okay, thank you. Leander.
Yeah, maybe I can add to that. I think one other thing to note in relation to where does it not make sense to use mass timber is, of course, timber is a lightweight material. So it doesn't make sense when you have like high acoustical requirements, like things like hospitals, for example. You know, there it would make less sense. I mean, you can still do it. There's also a lot of hybrid structures, but it's really looking at the properties of the material where you then define what makes sense and the availability of the material. Now there was this last question about height of the building. That's actually a quite an interesting one because we're doing a high-rise now in East Africa, and when you do a conventional building high rise, you're basically you design the building based on the earthquake requirements. Now for timber, that's different because you have much less mass, so you are actually restricted by the hurricane forces. And this is again a very different way of looking at it. So you will see that the building will act differently in terms of, and that is where it does make sense to build with timber. And actually, that not so many people know that mass timber was invented shortly before a huge earthquake in Italy, and it actually grew big after that earthquake because they could rebuild these houses very quickly and build them also more earthquake resistant. This is where mass timber took off. So that is, for example, like an example of where timber buildings make a lot of sense there where you have a lot of earthquakes. So, you know, we can talk 8 hours, I think, about it. I think LEED and these kind of things, it's great. It's a great tool. I find from my own experience that a lot of these things and certifications are developed for a certain region. They not always make as much sense in other regions. So, for example, we in Zanzibar don't apply a lot of these certifications because they're just not tailored for the region we're in. They're relying heavily on technical measures, which we try to eliminate as much as we can because they're high upkeep, they are energy consuming, and you can circumvent them by passive measures, which are not part of any certification process. So that is, I think, covering hopefully a lot of the questions which were out there.
Yes, I believe that most of the questions have been answered. I would like to recognize Dr. Daniel Akirimale. He's online all the way from Australia, I think, or New Zealand, somewhere so far away. You are welcome. And all our friends and colleagues that are online, we thank you for staying with us for so long. It has actually been an educative journey, very interesting, very informative, and very mind-opening, and you know, it gives us a lot of hopes in the built environment of Nigeria. Once again, I want to say a very big thank you. Our next webinar will be on the third Wednesday of September. So we would invite you to please also be our guests once more. And please, you can visit our YouTube channel to check out on past videos of the webinars that we've had, webinars 1, 2, 3, and of course this one, which is also live streaming as we speak. You can go back to Mass Timber Construction Nigeria. That's our YouTube channel. Please subscribe, like, and share so you can refresh your memory on all that we have. And we also have a LinkedIn page. I think Ibukun corrected me the other day, and we are also on LinkedIn. That's Mass Timber Construction. And we are also going to be issuing certificates very, very shortly in a short time on the past webinars. We'll give the certificates to those who require them. We've already gotten a few requests, and we're working on this, and we'll just do this and email them to you. So once again, thank you very much, everybody, for being participants at this enlightening webinar. And I hope that you have gained, your 2 hours has been very, very profitable for you. And I look forward to when we are able to implement these strategies in Nigeria. Thank you very much. God bless us all.
Thank you very much, Damien
Thank
and
you.
Leander. Thank you very much.
Thank
Thanks,
you.
everyone.
Thank you.
Thank
Thank you.
you, Architect
Bye.
Ajayi. Thank you. Thank you, everybody.
Thank you.
Thank you.